Hi students, in this lecture I am going to discuss first centrifugal force and after that banking. Let us see first one coming to centrifugal force. It is nothing but pseudo force. So we have learned earlier pseudo force means let us take there is a lift inside which we are taking a block attached to the ceiling with the help of string. So when we solve the question from lift frame which has acceleration. Since lift frame is non-inertial, we have taken one extra force, that is a pseudo force, which is equal to that pseudo force. I am taking suffix p, pseudo force, that is equal to mass of the block into acceleration of the reference frame, or I can say including direction part minus seva. This is a calculation of pseudo force. Now exactly same thing in settler motion, that is let us take let us take an electron moving in circular path around nucleus. So when you see from ground frame, its path is now circle and centripetal force is given by the attractive force of the nucleus on electron. So net force is now that attractive force, which is centripetal force, that is equal to mass into centripetal acceleration. Suppose we are taking now with respect to electron. I am repeating. Now we are taking with respect to electron. So when we are taking with respect to electron will be at rest. That means now it is in equilibrium. The net force acting on electron should be equal to 0, right? So you can see in that case, one is centripetal force, no change in that. That is attractive force. Second one is pseudo force, which is equal to mass into centripetal acceleration. So centripetal force is balanced by centrifugal force. Is balanced by centrifugal force. That means it is nothing but a pseudo force. So when you are taking now in circular path with respect to that particle, that pseudo force is named as centrifugal force. So here both are balanced. So same calculation what we have done in Newton's laws of motion while learning pseudo force. Okay. Let us now go to the next concept, that is banking. Let us see what is it. So earlier we have learned that when a two-wheeler taking turning on a horizontal road, we have to bend the vehicle. So without bending vehicle, taking turning is not possible. So by bending the vehicle, we are getting centripetal force, which is provided by frictional force, right? But remember, bending every vehicle like this is not possible. Like a three-wheelers, four-wheelers, that is not possible. And one more thing, suppose if you see on a rainy day, frictional force will be very less. That means we cannot depend on friction to get centripetal force. So for that, what we are doing is we are elevating the road. For example, let us say AB is a road. Now we are elevating the outer edge of the road like this. You can see now like this. This is now present road AC. So this is now outer edge. We are elevating the outer edge of the road so that one component of normal reaction provides centripetal force. Let us see carefully. Initially road was AB. Now we are elevating the outer edge of the road. Okay. So this is now AC is road and vehicle is now going into the plane of the paper, or you can see into the plane of the board. Okay. See how many forces acting on the vehicle. Normal reaction, normal to the road, mg vertically downwards. Now see the plane of the circle. That will be now. This is now plane of the circle. This is now center of the that curved road. This is center of that curved road. So you can see here now one component of normal reaction. So first we focus which force we have to resolve. This is now plane of circle. mg is now normal to that plane, and we have learned that along z direction net force must be equal to 0. Z in the sense we have taken circle is now in xy plane. Therefore, normal to the plane of circle, that is z axis. That's why fz equal to 0. Therefore, one component of normal reaction has to balance gravitational force. So here what we can do is, this is a theta. This also theta, right? Normal to incline. This is normal to horizontal, n cos theta. So one component of normal reaction is balancing mg. Means there is no net force normal to a plane of circle. Now remaining component is providing centripetal force. The advantage of elevating the row is one component of normal reaction providing centripetal force. Or we can say the same thing as resultant of normal reaction and gravitational force is providing centripetal force. So we have discussed the same logic while discussing conical pendulum. In conical pendulum, we have discussed that one component of tension providing centripetal force, or the resultant of tension and gravitational force is providing centripetal force. Exactly same logic. Okay. So n sine theta is providing centripetal force, which is equal to mv square by r. Okay. And see how we are taking this banking. So we are elevating the road in such a way that even though there is no friction, vehicles can take turning safely. I am repeating. We are taking the banking in such a way that even though there is no friction, we can take turning safely. So that's why in this we have not taken friction, only normal reaction and gravitational force. Let us say this is a speed. Let us take it as V naught. So V naught is a speed corresponding to which there is no friction. Okay. Then see from this what we get. So tan theta is equal to V naught square by RG. This is a relation between angle of banking and speed, because for a given road R is fixed. So on that road, once we're fixing angle of banking, speed will be fixed. So this is the speed for which there is no frictional force. But if speed is beyond this one, or if speed is less than this value, then friction comes into picture. Okay. Let us see how to calculate what can be the maximum speed and minimum speed. Let us solve this. And to understand this, let us take the diagram from the vehicle frame. So vehicle frame means it is non-inertial frame. Angle is theta. Suppose this is now vehicle. We are solving from vehicle frame. Then see how many forces acting on the vehicle. So one is mg downwards. Mg downwards. Normal reaction. Normal to incline means normal to road. Because road is now this inclined plane. Next, since we are solving the question from vehicle frame, we have to consider pseudo force. That is what we call centrifugal force. And that is away from center, m r omega square. So if you observe in ground frame, only two forces, normal reaction and gravitational force. But coming to here, apart from those two, one extra force, that is pseudo force, known as centrifugal force, which is away from center, right? Because center is now somewhere here, because the path is now circle like this, right? Now, from this, what we can say is, from the frame of vehicle is in equilibrium. Therefore, there is no net force acting along the road, along the road. Then see components along the road and normal to road. So we are resolving now components along the road and normal to road. Then see what we get. Resolving mg and pseudo force. This is mg cos theta and a component of pseudo force normal to the road, that is m r omega square. See carefully, angle made by this with incline is theta. This is now m r omega square sin theta, m r omega square sin theta. Now take components along the road. Along the road, m r omega square cos theta, and this is now mg sin theta. So now we want to calculate maximum speed and minimum speed. Let us see how to get it. When speed equal to v naught, when speed equal to v naught, so I have taken here m r omega square. Let us take in the place of this m v square by r. Okay, because we want to get speed, right? M v square by r. Then see what we can do here. So along the incline, when speed equal to v naught, we can write mg sin theta is balanced by mv square by r, mv square by r cos theta. This is velocity v naught. Then see from this we are going to get mass gets cancelled. Mass gets cancelled. It is now tan theta is equal to v naught square by rg. That is what we got by solving from ground frame, right? Right. So for this speed, there is no friction. Suppose now speed is more than v naught. Speed is more than v naught. Then what happens is this mv square by r cos theta will be more than mg sin theta. So here mg sine theta is a constant. When speed is more, when speed is more, mv square by r cos theta will be greater than mg sine theta. The vehicle has a tendency of slipping up the road. I am repeating. Vehicle has a tendency of slipping up the road. Then friction will be down the road. Okay. When speed keep on increasing, this friction also keep on increases. And at one point of time, friction becomes limiting value. Friction becomes a limiting value. Let us write equations here. Let us make a diagram here. So we are taking velocity greater than V naught. Then vehicle has a tendency of slipping up the road. Right. See carefully. Right. It is. So taking condition that V greater than V naught. Therefore, mv square by r cos theta is dominating. So mv square by r is dominating. So since it is dominating, it tries to slide up the road. So friction will be down the road. Already having here mg sine theta plus frictional force which is static. As speed keep on increasing, to balance that force, frictional force also increases because mg sine theta is a constant. But at one point of time, frictional force will be equal to limiting value. So beyond that speed, it cannot balance. So for one value of velocity, vehicle tries to slip up the road. That is now maximum velocity to move on the road without slipping up the road. So at that time, what we can write is equation is when you are taking velocity maximum. Let us take V1 as maximum velocity. V1, then equation will be mv square by r cos theta should be balanced by limiting friction, that is mu s into normal reaction plus mg sine theta. This is equation. Okay. And take in the place of V, it is now V1, that is maximum speed. And coming to here, n equal to, see what we get here, n value, n equal to mg cos theta plus mv square by r sine theta. So take in the place of it is V1, maximum velocity. So by substituting in the place of n this value, right, then we can get the value of V1 because remaining all values are known. That means theta is known, mu value is known. Right, like this, by using these two equations, we can find maximum speed. Right. Let us calculate now what is the minimum speed. So when speed is minimum, vehicle is having a tendency of slipping down the road. It has tendency of slipping down the road. Then friction will be up the road. I will make diagram here. Friction will be angle theta. Let us take V2 is minimum speed for which vehicle slips down the road. Okay. So now force equation. Now force equation mg sine theta down the road. So here centrifugal force mv square by r. V is now V2. mv square by r cos theta. But in this we are taking V2 is now minimum. Means for this speed, vehicle tries to slip down the road. While moving on the road, it tries to slip down the road. So friction will be up the road. So when it is about to slip down, friction becomes limiting value. Therefore, we have to write equation here. mg sine theta should be balanced by limiting friction plus limiting friction plus m v2 square by r cos theta. Now in the place of that limiting friction is now mu into n. Let us take here n value as n1 to avoid confusion, and this take it as n2, mu n2, where n2 equal to, where n2 equal to, it is mg cos theta, mg cos theta plus m v2 square by r sin theta. So by taking this n2 value here, we get f limited. Now substitute that here. Then we are going to get the value of v2. So by using this equation, we can get maximum speed. And by using this equation, we can get minimum speed. If the speed is less than this v2, vehicle slips down the road. If the speed is beyond this v1, vehicle slips up the road. Therefore, in between these two speeds, vehicle moves without slipping either up the road or down the road. This is now lower limit and this is now upper limit. Okay. Let us now focus one problem. See what is a question given. A hemispherical bowl of radius r is rotated about its axis of symmetry, which is kept vertical. A small block is kept in the bowl at a position where the radius makes an angle theta with the vertical. The block rotates with the bowl without any slipping. The friction coefficient between the block and the bowl surface is mu. Find the range of the angular speed for which the block will not slip. Okay. Let us see how to solve this one. Just now we have discussed angle of banking, the concept of banking. So why we are taking banking means we should not depend on friction to get centripetal force. That's why one outer edge of the road is now elevated. That is what we call banking. And we have seen maximum speed and minimum speed. Using almost same concept now here also. This is now hemispherical bowl which is now rotating about its axis, which is vertical. And condition given that there is a block or a particle, the line joining center of the bowl and a particle makes an angle theta with the vertical. He's asking the range of values of omega for which it does not slip. Okay. So now we are going to solve this problem with respect to that particle. See how is that? Now this particle follows since a bowl is rotating, rotating, you can see the particle follows now circular path. It is now like this. This is now circular path. Okay. And see, this will be now center of that circle. See how many forces acting. mg downwards, normal reaction towards center of the bowl. Let us now solve this question with respect to that block. With respect to that block. Then we have to take pseudo force that is known as centrifugal force, which is away from center. That is m r omega square. Okay. In this r is nothing but r sine theta. I am writing here r equal to r sine theta. Right. Radius of that circle is r sine theta. Now see what we can say. Since we are solving with respect to the block is now stationary or it is in equilibrium. Let us take here one tangent at this point, and this tangent makes an angle theta with a horizontal. If you see carefully, it is just like just now we have discussed that angle of bank, right? This incline looking just like a road where outrage is elevated at mg normal reaction and centrifugal force. And we have taken that along the road net force equal to 0. So exactly same logic. For this vehicle, for this vehicle now, sorry, for this block along the tangent, for the block along the tangent, net force equal to 0. Okay. So I'm taking now components along the tangent and normal to the tangent. So normal to tangent. It is mg cos theta. And for pseudo force, mr omega square, mr omega square sine theta. And along the tangent, mg sine theta. And this is now mr omega square, mr omega square cos theta. The same as the previous one. So when omega is maximum, means when you take upper limit maximum, it has a tendency of slipping up the bowl. It has tendency of slipping up the bowl. Then friction will be down. So I can write here mg sine theta plus having a tendency upwards, so friction is downwards, plus limiting friction, that is equal to mr omega square. I'm taking it as omega 1 maximum value, mr omega 1 square cos theta, mr omega square cos theta, and f limiting as usual mu s into normal reaction And normal reaction is, it is known that mg cos theta plus m or omega square sin theta, right? That is n value, right? In the same way, to find minimum omega value, when omega is minimum, it has a tendency of slipping down the tangent, means down the bowl. So down the bowl means friction will be up the bowl, means up the tangent. Therefore, equation will be mg sin theta is balanced by frictional force. Take it as this is FL1 to avoid confusion. FL2 plus m r omega 2 square cos theta. Now in this FL2 is equal to mu s into, let us take this as normal reaction n1. This is now n. Okay. So only change is n1 means taking here omega 1. N2 means again same value but take here omega 2. Okay. I will write here N2 means mg cos theta plus m r omega square omega r2 omega 2 square sin theta. And n1 is same mg cos theta plus m r omega 1 square sin theta. Then we have to solve. These two we have to solve, and these two we have to solve. So same as the previous question, that banking, their vehicle slips up the road or down the road. Here block slips up the bowl, down the bowl. So like this we can use centrifugal force, right? And bank. So I hope you got clarity.